Hello everyone, this question requires us to prove that the summation of r squared for values of I from 1 up to n is always equal to n open brackets n plus 1 close brackets open brackets to n plus 1 close brackets divided by 6. Now we are going to check the validity of this expression on the left hand side and on the right hand side. But we are going to begin for values of n which is equal to a 1. Okay, so we are going to check left hand side and then on the right hand side. So on the left hand side of the equation we have r squared, so we are going to say that this is 1 squared, and 1 squared gives us a 1. On the right hand side we are going to get n is equal to 1. We substitute where we see n, and this is 1 times, when I substitute here a 1, I'm having 1 plus a 1, that is a 2, then times, when I substitute here n is equal to 1, I'll have 2 times 1, that is a 2, then 2 plus 1, that is a 3, everything divided by a 6. So 1 times 2, that is a 2, 2 times 3, that is a 6, 6 by 6, we get 1, okay? Now it is clear that left hand side is equal to the right hand side. And since left hand side is equal to right hand side, then we are going to say the formula is valid for value of n is equal to 1. Now since it is valid, we are going to move for the next value of n which is equal to k. So we are going to say let n is equal to k, okay, and uk is equal to, we are going to get this k, we substitute where we see r, so this is a k squared. So the summation of r squared from I is equal to 1 up to n is going to be equal to, so for n is equal to 1, we say that that is a 1 squared, then plus, for n is equal to 2, this is a 2 squared, plus, for n is equal to 3, we are going to get a 3 squared, for n is equal to 4, that is a 4 squared, so that's why we are going to say plus other terms between, then plus, when we get this value of n which is equal to k and substitute it there, we are going to have a k squared, and everything is equal to, now we substitute a k on the right hand side, so that is a k into, we substitute a k here, that is a k plus 1, and the same applies here to have a 2k, then plus 1, everything divided by a 2. Now when we reach this step, we just say assume that this formula, assume that the formula is valid for the value of n is equal to a k. Now since this one is valid, we are going to go for another value of n which is equal to a k plus a 1. We increase the value of k by 1. What does that mean? uk plus 1 is also going to be equal to, we get this k plus 1, we substitute where there is r, so we shall have k plus 1, everything squared. Now we are going to add k plus 1 squared on both sides of the of the equation, and when we do it, we are going to have 1 squared plus a 2 squared plus other values, then plus a k squared. Remember, we said that we are going to add here a k plus 1 squared, so this is plus a k plus 1 squared, everything is equal to, on the right hand side we have k into k plus 1 2k plus 1 divided by 6, then plus we add a k plus a 1, everything squared. Now some students, when they reach this point, they don't want to simplify the expression, yet it is a crucial part. So let's proceed. I'm going to start from the right hand side. Remember, we need to simplify the expression. So when we realize here k plus 1 and k plus 1 is common, meaning that we are going to factorize the bracket including a k plus a 1. And when we do it, here we are going to be left with k times 2k plus 1. So when I say k times 2k, I'm going to be left with 2k squared, then plus k times 1, I'm going to have a k, everything divided by 6. Remember, we have factorized out k plus 1, so we are going to be left with a k plus a 1, everything divided by a 1. Now I'm going to get the LCM of 1 and 6. So that LCM is 6. So 6 by 6, that is a 1. 1 times 2k squared plus k, we remain with the 2k squared, then plus a k. So we have 6 divided by 1, that is a 6. 6 multiplying this bracket, we are going to get a 6k, then plus a 6. Now when I reach this point also, I'm going to add the like what? Terms. So when I do it, I'm going to have k plus 1, open up the brackets, 2k squared, then plus a 7k plus a 6, everything divided by a 6. Now at this point, we realize that there is a quadratic expression inside the square brackets. So we have a 2k squared, then plus 7k, then plus a 6, where the sum is 7 and the product of 2 and 6 is 12. So we need two values or two factors such that when we add them, we get a 7, and when we multiply them, we get a 12. So that is a 4 and a 3. Reason being, when we get 4 times 3, we get a 12, and when we add 4 onto a 3, we get a 7, implying that this expression can be written as k plus 1 divided by 6 into 2k squared plus a 4k plus a 3k, then plus a 6. Remember, we are doing this such that we can simplify. So let me group these terms. This one grouped with this, and then this one grouped with that. So I'm going to have k plus 1 divided by 6 into, now when we look at this bracket, the common factor is 2k. Yes, so I'm going to take it out, and when I factorize it out, I'm going to be left with a k, then plus, when I factorize a 2k from a 4k, I'm going to have a 2, then plus, upon this bracket, 3k and 6, the common factor is a 3. And when I factor it out, I'm going to have a k, then plus a 2, close brackets. Now, when we look closely, k plus 2 is common, so I'm going to also factor it out. So this is a k plus 2. And when I factor out k plus 2 from this term, I'm going to be left with a 2k, then plus. When I factor out this k plus 2 from this term, I'm going to have a 3, everything divided by a 6. And this is the simplified form of the other expression. And when we reach here, we are going to say, hence, the formula is valid for all integral values, positive integral values of n starting from 1, 2, 3, up to a k plus a 1. Thank you for watching. Don't forget to subscribe, like and share the video for more about math.